So the recording is going. And all right. The following Zoom session is being recorded. Let's go back one. Here we go. Okay. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, first of all, I have some business items to take care of. I haven't checked this morning, but as of last night, about half of the students that are in this class had not yet created a WebAssign account. So I just want to say this, you're going to have an assignment tonight and it's due by tomorrow night. And the only way you can access it is through WebAssign. So if you've gotten the materials but haven't signed up yet, you need to do that. If you've ordered the materials from the bookstore, including the WebAssign information, but it hasn't arrived yet, what you can do, you can still create an account in WebAssign using your email address and a password. And once you create that account, use that that student access number, student key code that I gave you in your syllabus. That should get you into an account. But when you do that, you'll notice that it says it's a free trial and it only lasts a few days and then it's going to expire. So if you haven't gotten the material yet, because it hasn't come from the bookstore, go ahead and create that free account, but you still need to get the stuff from the bookstore because otherwise that account is going to expire and then you'll be, oh, I can't get in and there's a test today. Well, too bad. You should have planned ahead, whatever. Okay. Anyway, if there are any questions about that, email me or come to the office hour at 1:15 and I'll clarify those things, but you do need to get signed up. A couple of other things I want to mention. The syllabus that I sent you, you need to print that out if you haven't already, and you need to read the whole thing. It has the schedule for the entire quarter. And what you'll notice is that, like, for instance, today, it says that we're going to be covering section 3.7. When is it due? It says due Tuesday at 11:59 p.m. Now, the mistake that a lot of students make is they think, oh, it's not due till Tuesday, so I'll start working on it on Tuesday. No. What you need to do is the day that it's assigned, not the day that it's due, but the day that it's assigned, go in and do the best you can with it. If you struggle with some things and you have some questions, then you email me and I'll get back to you. Or if you specifically say, hey, could you do this problem tomorrow morning during Zoom? Then Tuesday morning during this class time, I'll work out problems that you ask about. Then you can view them and still have time to finish up 3.7 by Tuesday night. Keep in mind, though, that Tuesday, there's another assignment, and it's a continuous process. But don't wait. You know, I've had students wait like an hour before it's due, and then they send me an email, oh, I couldn't finish, can I have an extension? Well, poor planning on your part is not an excuse for an extension, okay? Now, I realize things come up sometimes. There are things you have to deal with, but those are not the rule. Those are the exception. So again, section 3.7, is what we're going to be looking at today. Your goal should be to get it finished today. And then if you have some questions, ask about it so that tomorrow you can get it finished up. Okay, before I go on and start, do you have any questions about anything I just said at this point? All right, now, can somebody tell me this? You should see on the left side of your screen, you should see a grid and it's WebAssign. On the right side, you should see we will be covering section 3.7. Can somebody please verify that that's what you can see?
Yes, I can see that.
Thank you. The reason I ask is because sometimes I push the wrong buttons and like 5 minutes later, somebody will say, oh, Mr. Mayo, we can't see what you're talking about. So I want to make sure I've got the right stuff going on. Okay. So what we're going to be looking at today is graphing linear inequalities. Let's just do a rough or a quick review of what a linear equality is. Let's say I have 3x minus 2y is less than 10. That is a linear equality. All of the terms are first degree. We don't have any x squared or y squared or anything. And it has either a less than or a less than or equal to or greater than or equal to sign in the inequality statement. All right. So we're going to be graphing linear inequalities. One of the things you need to remember about solving an inequality, let's take this one I've written there, is you can add or subtract the same quantity from both sides to both sides of the equation. You can multiply or divide both sides of the equation by the same, or the inequality by the same non-zero number. But if you multiply or divide both sides by a negative number, you have to change the direction of the sign. So let's say we were going to, let's solve this for y, for instance. So I'd subtract 3x from both sides. I'd get that. Then I would divide both sides by -2. But in doing so, I'm going to change the direction of the inequality. Okay, so that would be solving that inequality for y. But again, multiplying or dividing both sides of an inequality by a negative number, then and only then do you change the direction of that inequality sign. All right. Now, I've already had some inquiry from students as to how to graph using WebAssign. It can be tricky. So you really need to pay attention to the process. And again, if you can't, if I lose you this morning, everything, you can always go back later this afternoon to my YouTube channel, Math with Mayo. It'll be on a playlist. It'll say Math 93 Fall 2021. And that video will be there as soon as I have a chance to upload it this afternoon. All right, so let's go ahead and take a look at an example. Here we have x plus y is less than 2. We are going to graph this linear inequality. The first thing I'm going to do is take the inequality and change it into an equation. Okay. Then I'm going to take that equation and I'm going to find 2 points, 2 ordered pairs that represent points on the graph. Now, I can choose any x or any y value I want, but keeping things small and uncomplicated is mostly to our advantage. So what I'm going to do, I'm going to find the x-intercept by setting y equal to 0. And then I'm going to find the y-intercept by setting x equal to 0. I don't always have to use the intercepts, but often it's good points to choose. All right. If y is 0, I get the following. X plus 0 equals 2, which means x equals 2. So 2, 0 are the coordinates of a point on the graph of x plus y equals 2. As I'm going along, if you have any questions, feel free to jump in and say, hey, wait a minute, you lost me there. Okay. All right. Next, if x is 0, we get 0 plus y equals 2, or y equals 2. So now I have 2 ordered pairs that represent points on the graph of x plus y equals 2. 2, 0, and 0, 2. However, I'm actually graphing an inequality, not an equality. When it does not include, well, let me back up a second. If I were going to graph x plus y equals 2, the graph of that would be a straight line. Let's see, it would be going through there, and it would look something like roughly like that, okay? But because I'm graphing something that does not include the equal sign, I'm going to establish where this line is, but I'm going to make the line a dashed line because it's not including the equal to. Now, if I lost you there, don't panic, because this is what we're going to be doing today. We'll be doing lots more examples. Now, here's the part that's critical. In WebAssign, since I'm graphing a linear inequality, I'm going to choose the button that's the line, not points, not a parabola, not a circle, but this button. And notice I have several options. This is a line that continues on in both directions. This is a ray. It has an endpoint and then goes off in one direction. And this is a line segment that has 2 endpoints. We are graphing a linear inequality that needs to be a line. So I'm going to click on that until it turns blue. So let me go back here and let's see here. Well, okay, like for instance, if I click on that, that's not what I want, okay? It's got to be that one and it's got to be blue. Next thing I'm going to do is I'm going to plot these 2 points. Okay, I'm not going to use this point to do that. I'm going to plot the point 2, 0. How am I going to do that? Over here on the graph, 2, 0 is right there. Okay, and then 0, 2 is right there. So now I've plotted those 2 points and a line forms. But recall I said that the line is not going to be solid. If it was less than or equal to, it would include a solid line. I need to make that line dashed. Well, how do I do that? Well, I go over here and I click on the line, and here it makes it a dashed line. I also want to point out, notice here it has the coordinates of the 2 points that I plotted. This is important because if we have a point that we're plotting that has a tricky set of coordinates and we try and plot it on the graph and it won't let us, we can come over here and manipulate this and put in our ordered pairs that way. Okay, and we'll be doing that here eventually. All right, so now I've got this dashed line. Okay, again, because it does not include equal to, it does not include a solid line. This is a boundary, but it's not part of the solution. Okay, it's kind of like, let's say that you have a farm and you have a neighbor next door and you're trying to distinguish where your land is, but the neighbor owns the fence that separates the 2 properties. So you've got your land, then there's that fence boundary, but it's not yours. So it would be dotted or dashed. The next thing I need to determine is which side of this dashed line is the solution. Is it everything over here or everything over there? Okay, it's going to be what we call a half plane. So I need to pick a test point. I'm going to pick a point that's not part of the dotted line, but that's on one side or the other. I'm going to go ahead and pick 0, 0. As long as 0, 0 is not on the dotted line, it's a good point to choose, 0, 0. Okay, so I've got a test point 0, 0. All right. Now, we used the equation to solve it to get these points, but now we're dealing with the inequality from here on out. So I'm going to put that into that inequality statement to see if it's true. So if x is 0 and y is 0, we get 0 plus 0, which is 0. Is 0 less than 2? Yes, this is true. So our test point is good. That means that this point is in the solution set. So I want to shade everything below the dotted line. But to do that, I click on Fill. When I do that, this little thing appears and you go, okay. And then I'm going to click there and there's my solution. Okay. So my final answer, it's everything below, but not including the dotted line. All right. Now, if I come back here and I click this or click that, you know, I can change which side it's on, but it needs to be shaded on the bottom. And to complete the question, you don't just draw the dashed line, you have to shade the correct part. Now, I would now click on Submit Answer, but I'm using this grid even though, oh, I forgot about that. That is the actual problem. Okay. So let's click on the Submit Answer and see what it says. There's a check mark, so it is correct. All right. Any questions about this particular problem? Okay, so I'm going to clear this thing and I'm going to use this same graph, only now I'm going to be using a different inequality than what I had there. So I won't be submitting them. Let's see, this one says 5x plus 4y is greater than or equal to 20. Okay, so we have an inequality that includes the equal sign. So that means when we find that line, it's going to be a solid line and then everything either above or below it. So again, I'm going to consider the related equation. And I'm going to use that equation to find some ordered pairs to determine the location of the line. Now, As I said, you don't have to use the X and Y intercepts, but they're often easy points to choose. So I'm going to find the X and the Y intercept. Recall an X intercept is found by setting Y equal to 0 and solving for the ordered pair. A Y intercept is found by using X equals 0. Okay, so if Y equals 0, I have 5X plus 4 times 0 equals 20. 5X plus 0 equals 20. 5X equals 20. Divide both sides by 5 and we get X equals 4. So there is a point on the graph. Okay, let's find a second point. Let's let X equal 0. 5 times 0 plus 4Y equals 20. 5 times 0 is 0. 0 plus 4Y equals 20. 0 plus 4Y is 4Y. So 4Y equals 20. Divide both sides by 4 and Y equals 5. So now I have two ordered pairs that I'm going to use to plot the line. But notice the original line is greater than or equal to. So it's going to include the equals to part. So I come over here, click on the right one until it's blue. 4, 0 is right there. 0, 5 is right there. Now, I don't want to change it to a dashed line. I want to leave it a solid line because the original inequality includes the equals. Okay. My ordered
We own
pair.
the fence, right?
Sorry?
We own the fence, right?
Exactly. Yes, exactly. We own the fence. So now this is still the property boundary, but it's our fence. Good, good. Somebody's awake this morning. Excellent. All right, now, but which side of the fence is ours as well as the fence? Again, I can choose any point that's not on the line. 0, 0 is open, so I'm going to choose that. Okay, so test point is 0, 0. So we're going to plug that into our inequality. So 5 times 0 plus 4 times 0 greater than or equal to 20. 0 plus 0 greater than or equal to 20. 0 greater than or equal to 20. That is not true. That is false. So what that means is that our solution is not on the side of the line that contains 0, 0. Therefore, we can conclude that the solution is on the other side of the line. Now, if you're a little let's see, no, what am I trying to say? I was going to say insincere. Insecure, that's the word I want. If you're a little insecure about it and you're thinking, well, I'm not sure, then you could go back and pick a test point over here. How about that? 6, 6. Let's choose that to verify that that one works. Okay, so if I put 6, 6 in there, 5 times 6 plus 4 times 6 greater than or equal to 20, 30 plus 24, 54 is greater than or equal to 20. That's true. So I know now that it's on that side of the line. So it's my fence and everything above it. Okay, that's the complete solution.
That's a lot of property.
Well, actually, it's only about what, 3 square inches.
I'm talking literally here.
Yeah.
If you own all the airspace above your fence, that would be interesting.
That would be interesting. In fact, so just since you brought that up, the solution does not end at the edge of this graph. This
No, it
goes
doesn't.
on. It's like you've got this plane that's forever in all directions kind of thing. It's two-dimensional, but yeah. So this continues on out forever, so to speak. Okay,
The graph
now,
may be finite, but the space is infinite.
there you go.
But wouldn't you have more property on the other side of the fence?
Say that again.
But wouldn't it be more property on the other side of the fence?
Over here.
Yeah, no, on the other side. That's not filled.
That's not part of the solution.
No, but if you're talking just about property in general, you would have.
I think
Now-
I
now
think
you
my
guys-
joke confused.
Now you're taking my example too literally. No, this is the neighbor's property over here. Okay. There's property there, but it's not mine. All right. Now, if I were to click on submit answer, it would say it was incorrect because this graph is designed to solve that problem, okay? But I'm just using the graph as an example. So I'm not going to click submit on that one, okay?
Mr. Mayo, someone
Yeah.
has a question.
Oh,
They asked
okay.
where you got the 6 from.
Okay, and in fact, just to let you know, don't bother using the chat because I have enough going on with the different things there and everything. So I don't even look at the chat. I'm sorry. So if you have a question and you put it in the chat, I probably will never see it. Just kind of jump in like Abel's done here and say, hey, you know, I have a question about that. Okay. Now the question was, where did the 6, 6 come from?
Yes.
All right. Where that came from, let's go back here and let's clear all of this and let's go back to, so we had 4, 0 and 0, 5, and I wanted it a solid line. I was going to pick a test point, okay? I picked 0, 0 and determined that it was false. That is enough information for me to know to fill it on the other side of the line. However, I said, if you're a little insecure about it and you want to verify that it is on this side of the line, pick a point over here. So I basically just randomly picked some point on this side of the line and I just chose 0 or 6, 6. I could have chosen 8, 0 or 4, 8 or whatever, you know, but so it was just a random point that was over here. Does that answer your question? Okay. I'll take that as a yes. Okay, so I didn't have to choose 6, 6. In fact, I didn't have to do any of this because knowing that this was false told me it wasn't over here. But I'm just saying, if you want to make sure, you could pick a point over here now and verify that it's true. Okay, let's see what is in the chat here. Where do you get the 6 from? And yes, okay. All right, so we're going to start over. Another example. Let's see here. How about this one? Y is greater than X plus 1. Sorry, while I'm thinking of it, I did have a couple other things I wanted to tell people that I want to make sure that you get right away. So those of you that, well, it should have been all of you actually, that ordered the package from the bookstore. It comes with a loose leaf copy of the textbook along with a card telling you how to get into WebAssign. Apparently that loose leaf copy of the textbook, some of the chapters have different labels than what's in WebAssign. So like maybe chapter 7 in the loose leaf copy is actually chapter 5 in WebAssign, something like that. Okay, this first day, it's not an issue. When they come up, I will let you know. Also, there's a chapter 14 that's coming up on Wednesday. And for whatever reason, the loose leaf package, they didn't put chapter 14 in it. Sorry about that. I will be emailing you PDF files of chapter 14. Okay. But I also want to tell you that online in WebAssign, there is an ebook which gives you access to the entire textbook. So you really don't have to use the loose leaf copy. That's just if you prefer to have it in that form. But if you look there in your WebAssign account, there's a place where you can get to the ebook. Okay. But my plan, I haven't gotten it yet, but my plan is that when I get that chapter 14, I will be emailing it out to all of you if you need it. Okay. And again, as we go along, I'll try and remind you about that. All right, back to our regular scheduled program. So we're going to consider the equation y equals x plus 1. Again, I'm going to find a couple of ordered pairs. And again, I'm gonna just kind of stick with the intercepts. In this, I get a situation where if the graph goes through the origin, then we're going to have to find some other points. But for now, we'll do this. Okay. So if y is 0, I'm looking at this now, I get 0 equals x plus 1. If I subtract 1 from both sides, x is -1. So there's a point on the graph. If x is 0, y equals 0 plus 1. So y equals 1. So now I have my 2 ordered pairs. However, I'm trying to graph this thing, not the equation. This says y is greater than x plus 1. So the greater than symbol does not include equals to. So it is not going to be a solid line. It's going to be a dashed line. Okay, so come over here and get my blue box there. -1, 0 is right there, and 0, 1 is right there. I'm going to make it a dashed line because, again, it does not include the equals to. Okay, so now I've got to figure out which side of the line is it on. Okay, now, again, I can pick any point I want, but not on that dotted or dashed line. So again, I'm going to go with 0, 0 just because it's an easy one to calculate. Okay, so test point 0, 0. I'm going to put that into our actual inequality. 0 greater than 0 plus 1, 0 greater than 1. That is false. Oops, too many bars on that F there. Let's see, false. So that means 0, 0 is not on the correct side of the line, which means the solution is over here. Now, again, if you want, you could choose another point over here just to make sure that it's true. But if you pick a point and it's true, you've got the right side. If you pick a point that's false, you go to the other side of the line. Okay? Any questions about this example? All right, let's go ahead and look at another problem then. Let's see here. How about this one? Y is less than 3x. So I want to look at the related equation, which is y equals 3x. Okay, and I want to find a couple of ordered pairs, so we'll go ahead and find the x and y intercepts. If y is 0, I get 0 equals 3x. Divide both sides by 3 and I get x equals 0. If x is 0, I get y equals 3 times 0, y equals O. So here's that situation I was talking about where using the origin or using the x and y intercepts won't get us 2 unique points because the graph actually goes through the origin. So in this case, what I'm going to do is I can use the 0, 0, but I need to use a different point. How about if we let x equal 1? Did I lose anybody there? I understand why just x and y intercepts didn't give me 2 unique points. It only gave me 1 point. So now if x is 1, y equals 3 times 1, y equals 3. So 0, 0, and 1, 3, those are my 2 points. Okay. Now, again, my actual graph is not including an equal sign. So I want a dashed line, not a solid line. So we turn that blue. We've got 0, 0, and 1, 3. I want a dashed line. And I can't use 0, 0 as a test point because it's on the dashed line. So I want to pick some other point. How about 6, 1, the point 6, 1, okay? So test point 6, 1. I'm going to plug that into this inequality and see what I get. Okay, so x is 6 and y is 1. 1 less than 3 times 6, 1 less than 18, that's true. So 6, 1 is on the side that is the solution. So I'm going to go fill and then on that side. Okay. So that would be my solution. It's a dashed line. It's the neighbor's fence, but my property is on this side of that fence. Any questions there? All right. Let's take a look at another example. And let's see here. How about this one? Y is greater than -3. Well, now I've got an inequality that only has one variable. The related equation would be y equals -3. When you have an equation, a linear equation with only one variable, you get the following. If it's y equals a constant, you get a horizontal line. If it's x equals a constant or a number, you get a vertical line. Okay, so what does that mean? Well, y equals -3 is going to be a horizontal line going through 3. And let me just convince you of that. Suppose x is 0. What's y going to be? Well, y is -3. Suppose x is 1. What's y? Well, y is -3. No matter what, y is -3. Okay, so I'm going to go over here and I've got 0, -3, 1, -3. Oh, there's my horizontal line. Okay. Any questions so far? All right, now, but the actual inequality does not include equals. So my line needs to be dashed. Okay. Now, is it above the line or below the line? Well, it says y is greater than -3, so it's going to be above the line, but let's pick a test point just to verify it. How about 6, 2? Okay, let's use 6, 2. I could use 0, 0, but so test point, we'll use 6, 2. Okay, if I put that into there, well, let's see, x is 6, but x isn't even in there. So I've got what, 2 greater than -3? Is that true? Yeah, that's true. So if I put the 2 in for y, so that means what? That 6, 2 is a correct test point. Test point. So there's our solution. Okay. Any questions about that one? All right. Let's take a look at this example. It says x is greater than or equal to -4. Remember, on the previous one, I said that if x was a constant, it was a vertical line. So let's take a look at x equals -4. So that means x is -4, no matter what. Y can be anything it wants to be, because y isn't even in the equation. So let's see. We're going to plot -4, 0, and -4, 1. And there is our vertical line, like I mentioned. It includes the equals, so it's going to be solid, so I'm not going to change it. I'm going to leave it a solid line. Now, it says x is greater than or equal to -4. So where would x be greater than -4? Over here. So that's the side to fill, but I'm going to go ahead and pick a test point just to be consistent with the process. Test point. Let's go back to using 0, 0. I plug 0, 0 in there. X is 0, y isn't even in it, so I get 0 greater than or equal to -4, and that's true. So my solution is, it's my fence, and this is my land. Okay? Any questions about that one? All right. Let's see here. Okay. Trying to find one that's got, here we go. This should work. Okay. So we're going to go on to another example. This says 3x minus 3y is greater than or equal to -10. Okay. So already I can tell it's going to be a solid line. Can anybody tell me why I know that?
Because it's a greater than or equal to.
Because it includes the equal to, right? If it didn't have, let's see here. If it was just that, then it would not be a solid line. But since it does include it, it's going to be a solid line, right? Good. Okay, so let's make a table. And again, I'm just going to stick with X and Y intercepts. If Y is 0, I get 3X minus 3 times 0 greater than or equal to negative 10. 3X minus 0 greater than or equal to negative 10. 3X minus 0 is just 3X. 3X greater than or equal to negative 10. Divide by 3X greater than or equal to negative 10 thirds. Okay. I deliberately picked this because it's not a nice point to graph, so we'll talk about how to fix it. All right. Secondly, if X is 0, I get 3 times 0 minus 3Y. Oh, you know what? I should have been using, let me fix this here. I skipped an important step. My bad, sorry about that. And that is to look at the related equation. So this is what I'm using to find those. So those all should have been that. Sorry about that. Okay. So now 3X minus 3Y, 3 times 0 minus 3Y equals negative 10. 0 minus 3Y equals negative 10. Negative 3Y equals negative 10. Divide both sides by negative 3Y equals 10 thirds. Okay. Now, I need to graph negative 10 thirds 0. Well, let's see. If I took negative 10 thirds and I changed it to a mixed number, that would be negative 3 1/3. So let's see here. I'll go over here and we're going to go, let's see. So negative 3 1/3 0. That's right about there. Oh, it didn't graph where I wanted it to. It graphed at negative 3. Don't panic. Don't panic. Let's see. Our second point, 0 10 thirds. That would be like 0, 3 1/3. So 0 3 1/3 would be right about there. But again, it went to the nearest whole number, didn't it? Not to worry. Okay. So let's go back and look at the actual thing we're trying to graph. It's greater than or equal to, so it's a solid line, but I need to figure out how to change my points so they're what I want them to be. And that's where I come in here, okay? So the first point was negative 10 thirds, comma 0. Now, if you write negative 3 1/3, it's going to think you mean negative 31 thirds. So in the ordered pairs, don't use mixed numbers. Use improper fractions. So basically, this needs to be negative 10 thirds, 0, and then 0, 10 thirds. And now it moves it to the correct place. So if you can't get it to on the points you need, you come over here and fix it, okay? Again, don't use mixed numbers there because it doesn't interpret mixed numbers as mixed numbers. You got to use the improper fractions, all right? And again, we determined the line was solid because it included the equal to. Let's go with 0, 0 as our test point. So I'm going to put that up here. So 3 times 0 minus 3 times 0 greater than or equal to negative 10. 0 minus 0 greater than or equal to negative 10. 0 is greater than or equal to negative 10, so that's true. So 0, 0 is part of the correct answer. So there we have it. Okay. So there's a lot of things in WebAssign to graph that honestly, some of these things I could not figure out. I had to check with my colleagues that were more experienced with WebAssign when I first started using this. It's not real intuitive of knowing what to do, okay? For instance, A typical mistake is people start by thinking, oh, I've got to plot points. So they do that, okay? Well, then all of a sudden you got all these points, but it doesn't automatically create a line. We're not plotting points, we're plotting a line, okay? Later on, we'll be plotting what's called a parabola. We won't plot any circles, but anyway, my point is you've got to know how to use it. And right here, I'll always give the directions on my videos to how to do the graphing according to the way WebAssign wants it. All right. Have you got any questions at this point? Okay, so just a quick reminder. If you haven't already, print off and read your syllabus, the whole thing, not just the parts I referred to the other day. Look at the schedule. You know the entire schedule for the entire quarter. So don't email me 2 weeks from now saying, I didn't know the test was today. You know right now when all your tests are going to be. They're all right there in that syllabus. So read it. Okay. I will be back today at 1:15 at a different Zoom meeting ID as was in your syllabus. If any of you have any questions and want to come there to ask, I'll also be checking my email throughout the day. If some of you have questions that you want me to do tomorrow morning, specify that. Say, hey, Mr. Mayo, can you do section 3.7, problem number 12 tomorrow morning? Okay. If you need some immediate feedback, I will get to you when I have time. And most likely, depending on your question, if it's an easy question, I'll just answer your email. If it's more complicated, I will probably call you. And sometimes I'll even go as far as to say, let's create our own Zoom meeting right now so you can see what I'm doing, because a lot of this stuff, it's easy to explain when you can see it, but trying to explain it through an email or over the phone gets complicated. Anyway.
I'd argue that most math is that way.
Sorry?
I'd argue that most math is that way.
Yes, yes. Though I had a student once that went to the Philippines for a week during the middle of class. And so we could only use email. It was not really efficient and it was a lot of work on my part. Anyway, I will, if you come back this afternoon, I'll see you at 1:15. Otherwise, I'll be here tomorrow morning at 10:30. So have a great rest of the day. I'm going to go ahead and stop the recording.